Yo, what's up everybody, how's it going? So guys, today we are going to solve the another coolest problem, which is balance the binary tree. Yeah, you listen the right. We have to balance the binary tree. Let me just open my this thing. So I will help you to teach very easily using pen. So it work like pen and paper, which I really like. Alright guys, so what we are going to do today is so we have to solve this balanced binary tree. This problem is quite simple, so it's nothing very difficult. So basically what we have to do, we have to check whether the tree is balanced or not. Okay, so we have just given a balance factor. So by using that balance factor, we have to create a like we just create one formula: balance factor equals to left minus right. All right, so if this will be equals to 1, then the tree is balanced. So like how this thing will work in this one is, for example, let's say we are this is our root. All right, so we have to check is this balanced. So it has to be 1 for that. Okay, we have to check is it 1. All right, so let's check. So this is over here only one node. Okay, and over there it has one node, same. This 20 has one node, and this 3 has 20. It's a one node, so 1 plus 1 2. All right, so 2 minus 1 will give us 1. All right, so yeah, this tree is balanced. So that's what we got in our output as well as true. All right guys, so there is like a two ways to solve this problem. So one is we called top down approach. All right, and the another one is called bottom up approach. All right, so I will gonna tell you the both of them. So I will tell you which one is good, like according to the time complexity and all that. So first of all, we will use the top down approach. So top down approach, basically what it means, it means by its name, like we are going from the top to the down. Okay, we are going by its height. So that's what we're gonna do in this one. Alright guys, so let's get started. So first of all, we will create our base condition. If root is equals to null, then we simply return what we simply return true. Yes, now what we do, we will create a height function for this, so that we can calculate the height. All right, and I will call node over here. All right, so yeah, so what we do, I will just create a one base function over here as well. If node, we call it node. So if node is equals to null, then we simply return 0. So 0 means like kind of true, because integer we can't put in integer we can put true, so we have to put 0 like that. Right, so now I will calculate the max, which one is left or right, which one is max. So method max, by using that, so I will say height node dot left and for the right as well. Alright, and I will add +1 to it. Why I add +1 to this one? Because you know that 3, so this one will count it as 1 as well, so this will count as a height as well. Alright, so let me just calculate first. It's balance factor. So how we're going to calculate is, I will use math dot absolute difference function to calculate that, math dot abs, and I will say height root dot left, guys, minus height root dot right, and I will check if this is greater than 1, then I will simply return false. I hope this thing makes some sense. So let me just move this to over there. Right, so yeah, so this is what we did. So I return false, and after that I will simply return my this int function. I will return my height function as well. So I will say return is balanced root dot left. Alright guys, and is root dot right. Alright, let me just give a run hit. Let's see, is this working or not? Is there any compilation error? No, it's good. So I hope this thing makes some sense. All right, so if you like look at the this question downward, so this question is like basically is false because it's not balanced tree. Because if you carefully see, this tree has a balance factor of 1, this and this one has the balance factor of 2. So this one is not like it's not balanced tree because of the height as well, because you know how the height by the left and right, so it's not balanced. So yeah, let me just submit it. Let's see. All right, so as you can see, it's about 48.50%. Why is because the time complexity of this is O of n square. So let me just show you the time complexity is O of n square. Why is that? Because we are going level by level to the downside. Okay, so it's consuming too much time over there. All right, guys. So to solve that, we have the bottom up approach. So bottom up approach basically has a time complexity of O of n. So we will gonna do that one now as well. All right. So let's move to the question. Let me just make it to as normal. All right. So now what we're gonna do is we will go for the bottom up approach. All right, guys. So let's just do this. Similarly, we will create our first base condition. If root is null, then we will simply return true. Alright, guys. Now what we want to do, I will just again call the height function. Similar to that, and similarly I will create one base condition for this one as well. Alright, guys, now what I will gonna do in this one is I will just simply say like okay, let's calculate the height of left. So how we gonna do is I will just simply put height no dot left. Similarly I will do for the right as well, so just bear with me, so you will gonna understand like how what's going on in the code, so you will easily understand. It's not too hard, this code is not too hard. Alright, now what I will gonna do is I will calculate my balance factor in this. So I will call one function named balance factor. Alright, and I will say math dot absolute difference. Okay, and over here I will simply put left minus right. Alright, guys, and finally I will check the condition. If I have to check if the balance factor is greater than 1. So if balance factor is greater than 1, okay, and I have to check if the left is -1 or the right is -1. If so, that then we will just return false from here. So I have to do that condition as well to this one. So I will simply return -1 over here because -1 itself is like kind of false in this one. Alright, so finally I will return my math.max in this. I will say math.max of left or right, and lastly adding +1. Don't forget to do this. And I will over here call my height function. I will say return height root till not equals to -1. If this is not equals to -1, then we will do it. Let me just run this code. So we got something over here, balance factor. Okay, I think we did something wrong. Yeah, here we go. So let me just give a submit. So this one is will go for the I think 100%. Yes, as per expected. So guys, I hope you understand the question and the solution. So I use two approaches, top down and bottom up approach. So you can use anyone, which one you like, but just make sure about the time complexity the interviewer is asking, so you can tell the time complexity, so which one is good. Alright, guys, so thank you guys for watching this video. I will see you in the next one. Till then, take care, bye bye, and I love you guys.